So in this video we're going to follow RStudio and RStudio Cloud and implement. We've already implemented HDMA tidyverse, so we've done exploratory data analysis on tidyverse, and we're taking Halvarian's code from his paper our code for big data, new tricks for econometrics, Journal of Economic Perspectives. So we'll just copy this snippet of code, and I may make some changes, but minor changes. We'll copy that, and what we want to investigate is to apply the C-tree logistic regression and random forest techniques and use this on the HMDA Boston data and examine some of the results. Now, in part, of course, we're looking here at just the techniques, right? And that's going to be a large part of the discussion. In the background, there is the original controversy as to what degree race led to different patterns of mortgage approval success, and this was a paper that was originally developed by Manel et al. 1996. Okay, so let's go into the RStudio portal. And a couple of things. We were previously looking at pivot table tree in one of the previous videos, and we had done an exploratory data analysis using this code here. So I want to create a new script, a new file. So file, new, RScript, and we probably should give this a name, but let's paste in our script from Halvarian, from his paper, and then we could save this file, save as, so we have to save as, and maybe we should say C-tree logut and in addition random forest, right? Because these are the techniques that are going to be implemented here, and we'll examine the results, and maybe we'll indicate that it's HMDA. Okay, so let's save. Okay, and that now appears here, so we have it saved and it's in the cloud, and any modifications that we make we can include it. Now it's also prompting me to install. We've already installed Party. If we go into the packages, you'll find here we have the Party, so that package is installed. We have ECDAT, which is where we're taking the data from, ECDAT, so that's data for econometrics, so that's it's already installed, already available and installed, but I don't have random forest. So it's discovered that somewhere along here we have a reference to random forest, and it's saying let's install, so that it'll automatically find those and it'll trigger that prompt to install. And currently we're installing, so I might just pause while the installation takes place. Okay, so the installation is being complete, and we can see that here that the stop sign has been removed, and we can do a little check here just to make sure in the RStudio cloud environment that we do have random forest, and random forest is here, so that's fine. That's everything is okay. So to implement C-trees, we need to invoke load into the library, the library here, Party. Okay, so and library ECDAT. Perhaps we could clear this and run the code, and we can see it appearing over in this environment here. So let's just run it again. And the data HMDA, and we want to change the name of condominium to condo. So that's code introduced. All this code is from Halvarian, and we're going to set a seed, and that's just so that we can replicate results in the random forest. The random forest involves kind of slicing and dicing of different bits of the data set, and it does that maybe several hundred times, maybe several thousand times, and it grows a forest as opposed to a single tree, and then using majority vote predict whatever our dependent variable is that we denominate. So we start off here with C trees. Now, when we run our results here, we get what? We get, so first of all, we make that change we introduced before. So we go from purely the HDMA data, we just want to complete cases and put that into an object called all. We have that. Then we run a C tree, and we're trying to predict deny. And again, if we recall, deny was did you get the mortgage or not? So no, deny means you were approved. The vast majority of cases people got mortgages, but we want to use all the variables. So this notation here, deny, squiggle, space, and then full stop, that implies that we use all the predictor variables to try and predict the outcome in terms, or to model the outcomes here in terms of deny. Now, if we recall, we don't have the code here for plotting the C tree. We might just revert back to our files and look at the existing HMDA tidyverse R. So if we go back here for a moment and just come down towards the end, and we had some script, right, that ran the same C tree. So again, all fit C tree, and then we want to plot the all fit, that object, and let's just run that and see what's there. It's also presented in the paper, and let's zoom, and again, how do we interpret the C tree? The C tree is a conditional inference tree and allows us to construct a way to sort the different outcomes. So these terminal nodes here are what we might refer to as leaves in the tree, and this node here might be seen as being the root, and the root then, or this node leads to the other nodes in the tree. But ultimately what we're trying to do here is predict mortgage denied yes or mortgage denied no. So the logic would be, we if the individual was denied mortgage insurance, then overwhelmingly of the 48 cases in which that occurred, the vast majority of them were not successful in their mortgage application. So yes, they were denied their mortgage, and only a small, this white or grey area that signifies or signals that there was a few instances where people who were denied mortgage insurance actually managed to get a mortgage, but the vast majority wouldn't have got their mortgage. Whereas if we apply the criteria no, wasn't denied mortgage insurance, that means they obtained mortgage insurance, and that their credit score was less than 3, less than or equal to 3, so that's the better mortgage quality, and the debt service to income ratio was less than 0.43, and in turn the credit score yet again was equal to or less than 1, so that means in effect equal to 1, then out of this relatively large subcategory of 1,272, the vast, overwhelming majority of applicants were successful in getting their mortgage. Now, the C3, to understand perhaps a little bit the C3 here, one way we could, let's turn the graph off for a second. There's a help menu in RStudio and RStudio Cloud, so we can put in here question mark C3 and just run a little report in the help menu, and that should appear here. The conditional inference tree is the recursive partitioning for continuous censored ordered nominal multivariate response variables in a conditional inference framework. So that's what we've been just looking at. And then we set out the arguments, and the conditional inference tree estimates a regression. In our case, we're trying to predict a binary variable, a regression relationship, by binary recursive. So again, it was yes, no partitioning in a conditional inference framework. Roughly, the algorithm works as follows: test the global null hypothesis of independence between any of the input variables and the response, which may be multivariate as well. Stop if the hypothesis cannot be rejected. Otherwise, select the input with the strongest association to the response. So we're looking at the trying to predict were the mortgages approved or not. The association is measured by p-value, so there's a kind of a pruning that's taking place, and that's self-administered pruning or autonomous type pruning that we don't have to robustly engineer. So corresponding to a test for the partial null hypothesis of a single input variable and the response to implement a binary split in the selected input. So in the background there is a kind of optimization of error taking place, recursively repeat steps 1 and 2. Okay, so when we run that C3 and plot the output, this is what we're getting. The interpretation here, right, is fairly straightforward and very intuitive and very visually effective. And when we think back to our tidyverse HMDA analysis, some of the intuition that we may have garnered is reflected. So lower debt service to income ratio was associated with when the credit score was strong. We saw that when we did the facet wrap, that yes, there was a greater preponderance of red at particular cuts in the data. Likewise, these variables are highly interactive, and they shouldn't be viewed in isolation. And it's worthwhile considering pathways to particular outcomes. So for instance, if the credit score was higher than 1, but that would actually mean higher than 1, so that would mean 2 and 3, because we already on this track identified less than or equal to 3, so 2 or 3. If there is a public record of a finding against an individual, that would tip a little bit, that would prejudice a bit. More than 20% of those cases wouldn't have obtained the mortgage, would have been unsuccessful in obtaining the mortgage. But if there was no public record of bad debt, then the individual would appear, and the numbers here are quite significant, 479. The chances of obtaining the mortgage looked very good. So no, deny, no. The overwhelming majority here would have got their mortgage. If the debt to income ratio was in excess of 43% and the mortgage credit score was 1, we would observe here that many of those, again, the overwhelming majority of these would have been successful in getting their mortgage. If the mortgage credit score was 2, 3, or 4, then it became 50-50. Likewise, we can, if the credit score was greater than 3, we can see a different set of impacts here depending on these other variables. We'll examine this in the next video clip.